Good morning, students. Today I'm going to discuss recursive functions. In recursive functions, I'm covering these topics. One is recursive functions definition and recursive functions types. One is a direct to recursive functions. Another one is indirect to recursive functions. In these After completing these types of recursive functions, I am covering the two programmings, recursive functions for generating Fibonacci series and factorial programming and natural of two numbers. And advantages of recursive functions, disadvantages of recursive functions, and limitations of recursive functions. These topics covering in this class. Coming to the recursive functions. In general, programmers use two approaches to write a repetitive algorithm. It means that when the program developing or when the program implementing to following the two methods. One approach uses loops and another one is recursion. Another one is recursion. A function is said to be a recursive function if the function calls itself either directly or indirectly. It means that when the function recursive function using the function can be calling the itself or either directly or indirectly can only solve a base case when when you are using the recursive function in your programming can solve the base case only. In the recursive function using Fibonacci series, GCD, binary search, calculation of mathematical calculations, and reversing the numbers. And recursive functions are classified into two types. One is a direct to recursive function and indirect to recursive functions. One is direct to recursive function and indirect to recursive functions. And direct to recursive function. A function is said to be a direct to recursive function if a function calls itself from its own body. Function calls itself from its own body. Or our direct to recursive is said to be to occur when the recursive call to the function is made within its own definition. It means that when you are implementing a programming using directive recursive function, the variables or loopings, anything can be defined. It's within the body only, cannot define outside of the body. For example, I am taking the function 1 and I am defining the function only within the body, which means that within the square brackets only. Directive recursive function is a function called itself from its own body, or it's a definition within the function only. And the second one, indirect recursive function. A function is said to be an indirect recursive function if a function calls another function with it returns call with the first function. It means that when you are using indirect recursive function in your programming, the function one call with another function and it returns to call or it returns another function is called indirect to recursive function. For example, we have to take two functions. One is function 2 I am defining and function 1 is within the body I am defining. And here function 1 is calling and function 2 is calling within the body. Here f1 is indirect to recursive function because when the function 1 is calling within the body in f2 function and here function 1 is calling in direct to here, and this is the indirect to recursive function. And I'm going to discuss in this programming factorial using the direct and indirect to using the recursive function. I'm taking integer is a primitive data type, fact and int end with the semicolon, and void main when they take in the void no parameters calling to the void or no parameters written in the function. And taking the two variables in the function, one is n and another one is result. Int means primitive data type, integer, and it takes the memory location is 2 bytes. And printf is the standard input output function. Printf is the output function. When you are using the printf function, it displays the output, or when you are entering the program in displaying in the screen only. Scanf is the input function. I'm using format specifier D, and ampersand is the address of the location, and with the semicolon. In C programming, each and every statement end with the semicolon compulsory, and result equal to fact. N means number, end with the semicolon. Suppose enter any number, I am entering the 5, and result equal to fact 5, end with the semicolon. Printf, factorial of given number is percentage of d. It means that I am taking integer. That's why I am specifying the percentage of d in this programming. Slash and means next line, comma, result. It means that when you are printing the enter any number, that number can be displayed in the output screen. That's why I am writing the printf. Factorial of given number is format specifier d slash and next line and comma result and with the semicolon and end with the brackets. I am defining the within the body of the programming. After that, int factorial and int n. I am taking int n value is 5. If n less than or equal to 1, returns 1. End with the comma, and else return n star factorial n minus 1. This is the main important loop in the programming. When in this loop, return n asterisk factorial n minus 1. If the condition is true, the statement will be executed. If the statement is wrong, if the condition is not printing. If n less than 1, suppose I am taking n value is 5. 5 less than or equal to 1. It means that 5 less than or equal to 1 condition is true, return 1, and return n value 5 star factorial n minus 1. N value is 5. 5 minus 1, 4, and n less than or equal to 1, 5 less than or equal to, and if here return 1 means when the factorial value coming to the decreasing the order. After that 5, when you're taking n value is 5. After that n values are taken 4, 3, 2, 1. If n less than or equal to n, after that we are taking n value 0 less than or equal to 1 if the condition is false. That's why it returns one value. Here, if n less than or equal to 1, if the condition is true, statement will be executed. If the statement is false, return n star fact n minus 1 not will be executed. And coming to the flow chart. Step 1, call factorial 5. I am taking n value is 5. That's why fact 5 asterisk indirect operator fact 4. 4 means n minus 1. N minus 1, that is 5 minus 1, 4. And step 2, call the factorial 4. 4. It means that when factorial 4 means after n value taken 4, in the n value place of taken 4. 4 less than or equal to 1. It condition is true. That's why 4 asterisk factorial 4 minus 1. That's why here coming 3. And go to step 3. Call factorial 3. 5 is completed, 4 is completed, n. I am taking n value is 5. I am in this place of I am taking 3 asterisk factorial 3 minus 1, 2. 3 minus 1, 2 factorial 2, and call factorial of 2. 2 asterisk factorial 2 minus 1. The value is 1, and call factorial 1. 1 minus 1, 0. Factorial is 0. It returns 1. After that, it return 1. It means that when you are observing the left side programming, when the statement is if condition is false, it returns 1. If the condition is true, it will be statement will be executed. Step 6, return 1. After that, go to step 7, return 2 into 1. It means that 2, 1 into 2, 2. It means that 3 here, 2 value. And go to step 8, return 6. Return 6. 3 into 2, it means as 6. And step 9, return 24. It means that 4 into 6, 24. How they come here? 4 into 6 means 1 into 1, 1, 2 into 1 is 2, 2 into 3, 6, 6 into 4, 24, and step 10, return 120, 5 into 24. It means that 120. And also 1 into 2 into 3 into 4 into 5, the value is 120. 5 factorial is 120. And again, we have to see programming. Int if n less than or equal to 1. I am taking n value is 5. In this place of n value, you have to write first time 5, second time 4, third time 3, fourth time is 2, and fifth time is 1. And the 0 less than or equal to 1 statement will be false. That's why loop will be, if condition will be executed. If the how many times loop will be written 1 and condition is a true, n star factorial n minus 1. It means that 1 minus 1 that will be executed. In this chart also, you have to observe, I am taking 5 minus 1, 4, 4 minus 1, 3, 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0. It will be returns the value 1. And after that, completing the loop, they executing the value of the factorial. It means that 5 factorial is 120. Coming to the recursive function for generating the Fibonacci series, it means that to adding the adding two numbers is called Fibonacci series, and the main function is include studio.h. It means that standard input output header file. It means that when you are using printf scanner, you have to write in this programming stdio.h header file int Fibonacci series and with a semicolon, and int main. Int I am taking the data type is primitive data type int, and I comma n. They am taking two variables. One is I and another one is n, and with the semicolon. Printf enter a numbers. Printf enter a numbers, and with the semicolon. Printf means to displaying the screen of the output. Scanf means input of the program. Format specifier D. I am taking integer, that's why I am writing here format specifier D, and comma ampersand, and m is address of the n, and with the semicolon. And in the printf scanf, and a variable declaration can be end with the semicolon. And for I am using the loop for I equal to 0, I less than n, and I plus plus, and we are using the three statements separate with the semicolon, and for loop cannot end with the semicolon, and the function calling is printf format specifier D Fibonacci I end with the semicolon. Initially I value is 0 and n value also taken 0. And recursive function using this is the main function you have to develop the generating of the Fibonacci series. After the using of the recursive function int Fibonacci series int comma n, I am declaring it in the Fibonacci series integer and variable parameter. If n equal to 0, return 0. If n equal to 0, return 0. And else if n equal to 1, return 1. This is the recursion call the function, recursion calling. And else return Fibonacci series n minus 1 plus Fibonacci series n minus 2. and with the semicolon. If the conditions, these two conditions are false, exiting the loop. After that, they printing this one, this mathematical calculation. In this calculation, you have to take n value is initially 0, 0 minus 1 plus n value is 0, 0 minus 2. This is not valid of the function. And we have to take I value is 0 and n value is 0. That is the loop. And recursive of the Fibonacci functions, and after that Fibonacci series initial value 0 equal to 0 and Fibonacci 1 is 1, and after that second series 0 adding these two statements. One is Fibonacci size of 0 and Fibonacci series of 1. Fibonacci of 0 equal to 0 value and Fibonacci series of 1 equal to 1. And coming to the Fibonacci series 2 size 0 plus 1 1. That's why 0 1 1 and 1 plus 1 is a 2, adding up the two numbers. The Fibonacci series function will be recursively called itself until it reaches the base case. It reaches the base case. In this function, we are in the loop. Initial value 0, n value is 0. N value is 5 minus, and taking here n value is equal to 0, return 0. And 1 is 1. And after that, these statements are one by one true, this will be executed. If the statement is false, this statement will be not executed. And find the sum of the first n natural numbers using the recursive functions. Int find sum, and the name is find sum int n. If n equal to 1, if the taken n value equal to 1, returns 1. And return n plus find sum n minus 1, and with the semicolon. And int main function have to take printf format specified find sum 5, and with the semicolon return 0. This is the function of the first n natural numbers. You have to find, you have taken n values 5, 5 plus find sum 5 minus 1, 4, 5 plus 4. How to take, this is the loop generating when the loop is if n value equal to 1, and if the n value equal to 1 returns 1, and if the 5 in the main function find some values 5, after finding the result they return 0. Why return 0 means I am taking int main. And advantages of recursive functions. When you are using the recursive functions, the size of the code will be reduced with the recursive functions when compared to iterative functions. When you are using the recursive functions in programming, the code will be reduced. And when compared to the iterative functions, in the recursive functions, they are not using the loops. And programmers can easily write recursive functions without knowing much details about the programming logic. We have no idea in the writing of the programming. We are using this programming recursive functions. They easily to write and maintain the programming. These two are the advantages of recursive functions. One is they reducing the code, and when compared to the iterative functions, and programmers can easily write recursive functions without knowing the programming logic. And disadvantages of recursive functions. It is very difficult for the programmers to trace a recursive function manually. It is very difficult to identify the recursive function manually in the programming. The space complexity of recursive functions is more when they compare to iterative functions. Space complexity is very disadvantage in the recursive functions. They have to more the when compared to the iterative functions. The time complexity of recursive function is also more when compared to the iterative functions. It means that when you are using recursive functions, they taking the time complexity is high, and space complexity is also wastage in the using the recursive functions. These three are the disadvantages of recursive functions. One is trace the recursive functions manually and space complexity, and is another one is time complexity. And the limitations of recursive functions. You do need to understand the two major limitations of recursions. The first one is recursive function solutions may involve extensive overhead because they use function calls. Recursive functions using the solutions may involve extensive overhead because they use function calls. And the second one is each time you make a call, you use up some of your memory locations. When you are using the recursive functions in a programming, then recursive functions call to each time you have to make a call. Each and every time in a programming, you have to call the recursive functions. You use up some of your memory allegations. Every time you have to call memory recursive functions, that time you have to give the memory allocation in a programming. In this problem, you have to wastage of the some memory. If the recursive is deep, that is, if the program has large number of recursive calls, then you may run out of the memory. If the recursive function using in highly in the programming, large program of recursive calls, then you may run out of the programming. And recursive function differences with the iterative function. And any problem that can be solved recursively can be also be solved iteratively. It means that non-recursively. Any problem that can be solved recursively can be also solved iteratively and non-recursively. A recursive approach is normally chosen in the preferences to an iterative approach when the recursive approach more naturally mirrors the problem and results in a program that is easier to understand and debug. Understand debug means to identify the errors easily and rewrite the program, and to easily compare and execution the program is easier in the recursive and iterative programming. Another reason to choose a recursive solution and iterate an iterative solution may not be apparent. It means that when they using the iterative functions, to is a time consumption is less and to solution may not be appendant, and avoid using the recursive in performance situations. Recursive calls take time and consume additional memory. It means that when calling the any value in a programming, you have to use recursive call, and it take to time to call any value in the function body. And when you're calling the function in a body and it take to additional memory, it means that memory space is wastage is very high. Common errors by programmer. Accordingly, a non-recursive function may call itself either directly or indirectly through another function. It means that direct to recursive function and indirect to recursive function. When there is a direct to recursive function within the body defining the program, and indirect to is they calling another function within the body. Functionalizing the programs in a neat and hierarchical manner promotes a good practice. More easier to program, text, debug, maintain, and evolve. But it has a price. Highly functionalized program makes potential large number of function calls. When are using the recursive functions in programming, and it is a hierarchical manner and promote a good practice, and it is easy to write a program in within the body, more easy to program, testing, identifying the errors and solving the programs, and maintaining and storage and memory allocations are easy, but it has a price is highly functionalized programs makes a potential large number of the function calls. In this class, I'm covering these topics once again. Recursive functions definition and recursive functions types, direct to recursive functions and indirect to recursive functions, and recursive functions for generating the Fibonacci series factorial programs, and advantages of recursive functions and disadvantages of recursive functions, and the limitations of the recursive functions, and recursive functions versus iterative functions. And recursive functions, it means that it function is said to be recursive function calls itself either directly or indirectly. The recursive functions, both two types, one is the direct to recursive functions and indirect to recursive functions. And direct to recursive function means if function calls itself from its own body. It means that when the recursive function calls the function is made within its own definition. This is the example. Function one, and with the parenthesis and with the semicolon within the body defining direct or recursive functions. And coming to the indirect or recursive functions, if a function calls another function which in turns call the first function, it means that when you are defining the one function, that function can be called another function. The first function can be returns the value. Here f1 is the indirect to recursive function, and this is the factorial programming. The main one is this is the loop. If loop if condition is true, the statement will be executed. If the condition is false, the statement will be not executed. It returns the one value. Here the flowchart. Return 5 asterisk factorial n minus 1. N minus 1. That is 5 minus 1, 4. And after that, n value is n minus 1. It taken 4 value. After that, 3, 2, 1. When the condition, if condition is false, it return 1. After that, they calculating the values. 5 into 4 into 3 into 2 into 1. It comes to the answer is 5 factorial is 120. After that, Fibonacci series. When I use the main function and the recursive functions, they call the recursion call. It means that return Fibonacci series n minus 1 plus Fibonacci series n minus 2. When the values both are initial values 0, I value is 0 and n value is 0. After incrementing the n value, it means that I plus plus, I plus 1. Here taking I value is 0 and n value is 0. After that, I value is becoming 1. 0 plus 1, 1. After that, 1 value is again 2. After that, 1 plus 2, it value becoming 3. After that, I value is a 2, Fibonacci series n minus 1 plus Fibonacci series n minus 2. After that, 2 plus 3, 5. After that, 3 plus 5, 8. This is the generating of the Fibonacci series. This is the flow chart of the Fibonacci series, recursive Fibonacci function. The Fibonacci function can be recursively called itself until it reaches the base case. And after that, sum of the first n natural numbers. Here written n plus find sum n minus 1 and with the semicolon. And this is the advantages of recursive functions and disadvantages of the recursive functions. In advantages of recursive function is the size of the code will be reduced and program can easily write recursive functions without knowing the program logic. Disadvantages of recursive function is it is very difficult for the programmers to trace the recursive function manually, and space complexity of the recursive functions is more when compared to the iterative functions, and the time complexity of the recursive functions. This is the recursive functions topic.